Good morning, everybody, and thank you for attending this session, and welcome home. Today, I would like to give a short presentation of some results on the impact of the Urban Wastewater Directive on the European water quality, and this was a work that we did last year. First of all, I would like to acknowledge my co-authors, particularly Dr. Alberto Pistocchi, who was the leading scientist behind this assessment. And I also would like to point out that this work is part of a quite large Science for Policy report that has been published last year, and which is publicly available. So I want to be able to cover all the aspects, but you can go back to that anytime. So the Urban Wastewater Treatment Directive was launched in 1991, and it regulates the collection, treatment, and discharge of urban wastewater to protect the environment. So within the Better Regulation Initiative and the Regulatory Fitness and Performance Program, after 25 years from the inception of the directive, the European Commission wanted to have a retrospective evaluation of the directive. So I'm glad that Julia earlier this morning has given you the bigger context of how this kind of evaluation studies happen in the European Commission. So the Joint Research Center of the European Commission was asked to be involved directly on this assessment. How we went about this problem, we worked closely with the DG END, which is the European Commission part that work on the environment, to define what was the scope of the analysis, what were the scenarios, and also to clarify what were the expectations and what could be achieved in the time frame that we were given. And also a bit, of course, then there was time to collect baseline data and apply or adapt suitable models. And also we had a lengthy discussion about the interpretation of the results and how this should be properly presented for being important for policymakers. The scope of the analysis basically was what was the impact of the directive on reducing emissions of nutrients, organic matter, coliforms, and chemicals on the aquatic environment. And today I'm mostly concentrating on nutrients and organic matter, in fact more on organic matter. But for coliform and chemicals, you can always go back to the report that I mentioned. We defined 4 main relevant scenarios. Of course, the current conditions, and for the current conditions, we agreed that we could use the 2014-2015. This was the years for which we had the most current available data at the time. We needed also to evaluate what were the conditions before the directive, so in 1990. The future, which will be the full compliance of the Urban Wastewater Treatment Directive. But from a political point of view, it was also important to establish what if no directive. So what would have been the trajectory if a directory did not exist. And clearly this is an hypothetical condition. So together with our stakeholders, we consider that some countries probably would have progressed more quickly, others a bit less so. what if no directive scenarios probably was going to be in between the present conditions and the past. Another question that came out was the importance of individual appropriate systems. These are an alternative way to collect and treat domestic waste when collection and treatment in wastewater treatment plant is not economically convenient. So these appropriate systems should be equivalent to a wastewater treatment plant for that location. However, there is no mandatory channels or obligation to monitor effluents. So a question is, maybe they are not as effective as they should be, and what is the impact of that? So a first quick evaluation showed that in the European Union, IES treat from 0 to 16% of domestic waste, depending on the country. So clearly there can be an important regional effect on these individual appropriate systems. So after defining the questions and the scenarios, we started gathering data. The main database was the water-based database, which is published by the European Environment Agency. But we integrated it because it reports discharge point of wastewater treatment plant, agglomerations, and so on. But for small agglomeration, there is no data reported. So we had to integrate this information with national statistics and population densities. And the same approach of these national statistics was applied to regions which are not covered by the water base, and also for the past condition when water-based information was not existing. We had to evaluate not only population equivalence, which is what the water base reports, but also emissions of nutrients, BOD, coliforms, etc. And we had to differentiate the pathways because those are the ones that are important for political actions. So wastewater treatment plants, IES, agglomerations, disconnected populations, and so on. Then we had to evaluate what these emissions may have on the aquatic system. And for this, you need also to consider other sources of pollutants, and also consider processes that happen in the freshwater system on the way to the seas. So we use conceptual models that work at a catchment scale and are topologically connected from an hydrological point of view. These conceptual models are basically continental scale, and they consider sources of pollution from agriculture, industrial, urban wash-off, and also natural emissions to put everything in the context. And they are also calibrated using monitored data at the stations available at the European scale. So basically the green model was the initial model we had in the house, and we also adapted it for organic matter and for coliforms. So I will just give a short overview of the type of results that we presented at the end for the assessment. So there were, of course, maps. And the unit, the special unit of interest was the administrative unit, NUTS to scale for Europe. And in this case, we reported what was the percentage of rivers in kilometers that were below a certain amount of concentration for nutrients or BOD. So here on the left, you see the current conditions, and on the right, what would be the future with the full compliance. Another example of results is what is the impact to the sea. And here we have the different scenarios. What are the loads under the different conditions that reach any European marine region. Of course, also the U28 scale, what is the impact to fresh waters, again, in percentage of river length at given thresholds level. So we can see that conditions from the past to present and the future are going to improve the quality of waters, but maybe not to such a high level that we would have wished to see. This is for BOD. Of course, for phosphorus, the story is different. But that's because other sources are important. And for example, in the BOD, there is an important loads from livestock and from urban runoff. Finally, this is a most important output for our stakeholder on what can still be achieved with the Urban Wastewater Treatment Directive. So what are the loads of pollution that can be avoided by implementing the directive at its full potential. We can see that, for example, for BOD and nitrogen, there are sizable loads that should be tackled with better control of combined sewer overflow, it's the gray area, or urban runoff. And this leads us to the conclusion of the assessment, which is, yes, the Urban Wastewater Treatment Directive has reduced pollutant loads significantly, both in the fresh water and to the seas. So its overarching objective has been largely achieved. Some regions are still lagging behind, but they are on track. And with the full implementation, more gain will be achieved. However, some other sources, for example, from urban runoff and combined sewer overflows are important, and they are not clearly tackled in the directive as it is. So there might be space here for considering some reformulation. So this was the conclusion of the work, and now a bit my 2 cents of thinking about what is good in science for policy. I completely agree with Claire. Time is important. We need to spend time for basically getting the scope and the analysis right, and answer the questions that we want, and also to limit expectations to what is feasible. Transparency or uncertainty assessment. Well, I mean, of course, there is no clear antagonism between the two. Both are important. In this work, we gave priority on transparency, and this has created a good ground of trust and clarity in the assumptions. So the uncertainty became quite clear by definitions of what were the scenarios and so on. Peer review publication was extremely important for legitimacy of the use of science to inform policy in this exercise, and generally this is what we experience in our daily work. But we can also consider what are good policies for science, and again, giving time to develop tools that can be used when a question arises. In this work, we used a lot of data and models that were pre-existing to the exercise, and we could have not answered many of the questions if these were not existing. We also found out that, for example, for chemicals or coliforms, more work should be done, and it's in fact going to be done. But planning is a bit of a longer term matter. Also, people matter. Engaging is essential to build trust, takes time, and therefore too quick turnover of people in the institutions may create some delays in the understanding of each other. Among the policies for science, I think the open data policy at the European Union is extremely important. It allows to build on existing knowledge and reuse data that is out there. So I definitely think it's a big gain for all the community. And I just give you the references to the works that I cited here. And I thank you for your attention. If you need to contact me, please do so here or later.
Thank you, Olga. So we have time for one or two questions, if anybody has one. For me, it was great. Sorry.
All is clear.
For me, it was great to hear you reflecting on the role of the science there. One question that came up for me is that often once we get the results, it gives us an opportunity to reflect on whether we were asking the right questions to begin with. So in this case, do you feel that there would have been potentially other questions that would have helped better feed into the improvement of the directive or its implementation?
No, but we spent a lot of time in trying to understand what kind of outcomes they would be interested. Because of course it was not only about reduction of the emissions. This was relatively easily achieved. But the importance was, okay, what's the difference for the aquatic system? And we didn't completely resolve that, of course. It's a big question. I think we are moving toward that direction. But also we spend time in trying to, for example, to set significant thresholds. And currently, there are no single clear thresholds except a few for a few pollutants. Like, for example, BOD, some countries accept higher thresholds to define good quality or lower. That depends on a lot of considerations. So we had quite a suite of work in trying to define what was in fact relevant in this case. And I think that there is a good work going on at the European Union level to make it more homogeneous in our continent. Yeah.
Great. Julia, did you have a question?
Thanks a lot. It was an extremely interesting presentation, and the summary that you provided in the end of the challenges for science for policy, I think it's extremely relevant in this context. Particularly, I was impressed by when you mentioned that this work was indeed possible because there were data that allowed this retrospective evaluation, and how important it is then for policy to think ahead when devising a policy, to make sure that after the implementation, the data are indeed there to allow the ex-post evaluation to be done. Yeah. So I think that this is really, I was wondering if you had, because this is really an impressive piece of work, if you have any advice or best practice that you would like to share also with a wider modeling community beyond even the environmental field. What would be your takeaway lesson of this project? It's a difficult one.
It goes beyond my 2 cents. Well, definitely thinking about how to monitor progress is an essential part of a
Yes.
policy-making exercise.
Mhm.
I think the Water Framework Directive is much ahead in this. And in fact, it allowed to build a knowledge system at the European scale unprecedented. And we are just only now taking stock of its importance and its use within and a bit outside its immediate purpose. But definitely it helps having this kind of environmental directive in this case, but creating monitoring and sharing data that can be used for a wider community is one of the biggest benefit from my personal point of view of having European community policies in place.